One.
Hi and Assalamualaikum Doctor. Our group will present about powder metallurgy process. This group consists of 4 people, PREVEENA, Thipan, WAHIDUDDin and me, EZANIE, NADIA, BINTI and MOHIZAN. So we proceed to introduction. Powder metallurgy is a metal forming process performed by heating compacted metal powders to just below their melting points. It has become widely recognized as a
Yeah,
superior way
Shalini.
of producing high quality parts for a variety of
விலங்கல ஓகே
important
தான்.
applications over 100 years. Although the process has existed for more than 100 years, this success is due to the advantages to the process offers over other metal forming technologies such as fogging and metal casting. Advantages in material utilization, shape complexity, near net shape dimensional, near net shape, near net shape dimensional control, among others. These, in turn, contribute to sustainability, making powder metallurgy a recognized green technology. These are the advantages of powder metallurgy process. First, the parts can be produced clean, bright, and ready for use. Second, the composition of close dimensional tolerance can be achieved. Other than that, the machining operation is almost eliminated, and lastly, parts have excellent finish and high dimensional accuracy. So I'm going to pass to the next person.
In powder metallurgy, there is three major steps. Firstly is blending and mixing the powder. Second is compaction, and thirdly is sintering. So let's go into blending and mixing first. Blending means mixing powder of the same chemical composition but different size, while mixing is combining powder of different chemistry. So if we can look at this below picture, there is de- uh, devices that are used to blend the powder together. So first we have a rotating drum. The second is rotating double cone. The third is screw mixer, while the fourth is the blade mixer. So next, except for powder, some other ingredient are usually added to the mixing. First, for example, is lubricant. Lubricant is used to reduce the particle dye friction. The second is the binder, which is used to achieve enough strength before sintering. And the third is deflocculant. It is used to improve the flow characteristic during feeding. Okay, let's go for the compaction. Compaction is a pressing process. It's a blended powder are pressed in the dies under high pressure to form them into desired shape. So there are two types which can be divided of the compaction. First is the pressure, and the second which is pressureless. So under the pressure, we have cold isostatic pressing, we have hot isostatic pressing, high energy rate technique, vibratory compaction, continuous compaction, forging or extrusion. And while in pressureless, we have slip casting, gravity compaction, and continuous pressureless technique. So let's go first. Go into the cold isostatic pressing. So this is uh, the this is the picture of the cold isostatic pressing. So placement of powdering flexible rubber mold, hydrostatic pressure in chamber by water, and most common pressure is about 400 megapascal. Next, we have hot isostatic pressing, which is the powder container is usually made up of high bond sheet metal. Pressuring media is inert gas. It is common condition of 100 megapascal and at 1100 degrees Celsius. Its advantage is compared of 100 density, which good metallurgy bonding and have good mechanical properties. While its limitation is wider dimensional tolerance, greater cost and it time consuming. So this is Step for hot isostatic. First you fill the can, then you vacuum back out. Then the third process is where the heat coil inside the chamber, and so after the part is removed, this is the final product. So the next is about the high energy rate technique, which is exploit or spark discharge method are applied in closed die. The third one is a short time and have high pressure. It is also have high punch and die wear, which is limited tolerance and high cost. The next method is a vibratory compaction. It is a stimultaneous application of pressure and vibration, which is use of much lower pressure and is a use also use a complicated equipment design. So this is a continuous compaction. Apply to a simple shape such as a rod, sheet, or tube, maybe, and a plate. So it also have flowing loose powder between a set of vertically oriented roll at much lower speed. So this is a forging or extrusion. It's a canning of powder. It's heating or evacuation of sealed container followed by forging or evacuation. So the mechanical or chemical removal of container material. So I will pass to the next person to explain more about the compaction prejudice.
Thank you, Wahiduddin. So, as previously mentioned by Wahiduddin, compaction process exists in two ways, which will be pressure and pressureless. So, we will be looking at pressureless right now. So, there will be two kind of process that are going to focus in our presentation. So, first one is the silk casting, and the second will be continuous pressureless technique. Next slide. So as for the slip casting is widely used for ceramic, but only to a limited extent for metals. The process consists of preparing a slip powder containing a powder suspended by a liquid and additive to prevent settling down of particles. Then the slip is placed in a mold made of fluid-absorbing material to form the slip casting. After removal from the mold, slip casting is dried and sintered. This method is mainly used for relatively incompressible materials for conventional die compaction. The process definitely takes long time for the liquid to be removable from the porous mold. So we can see the diagram at there, a clear picture, a clear view of what the slip casting is. Second slide. So the second one that we're going to focus is the continuous pressureless technique. So continuous pressureless compaction is used to produce porous sheet for electrodes of nickel and cadmium batteries. The powder may be applied in the form of slurry to be coated on the metal screen or solid metal sheet to produce unusual composite. So above figure shows the techniques or the process of the continuous pressureless. So the next slide. So the third process after the compaction will be the sintering. So sintering is a compressed metal powder which is heated in a controlled atmosphere furnace to a temperature below its melting point, but high enough to allow bonding of the particles. So it's the purpose of the sintering will be to increase the strength and hardness of a green compact. So the principal variables that going to be considered during the sintering will be the temperature, which is generally between the 70 to 90% of the melting point of the metal or alloy, and the time, which is approximately 10 minutes to 8 hours, and with the furnace atmosphere. The sintering process is a concerned with diffusion, with surface of particles at temperature rises, and the densification decreases the porosity, increases the particle contact area, and the last one is the recrystallization and grain growth between the particles at the contact area. So above the figure, we can see the sintering stages. So at first point, the diffusion of atoms between adjacent particle surface at the point of contact, which leads to development of grain boundaries among themselves. So we can see the point bonding, and the next as the sintering process develop. So next will be the newly formed bonded areas grow in size by diffusion of atoms across the grain boundaries, and the last one will the growing size of the bonded areas resulted in the formation of pore within the grain of larger particles by volume diffusion of the atom. Finally, with the time, the pores are eliminated completely and a single unit of solid mass is produced after sintering over. So next slide. So as we can see from this slide, sintering process consists of two kind of classified into two groups. So one with a solid phase sintering, and the second will be liquid phase sintering. So for the solid sintering, neither of the compacted metals melt, but grain growth and diffusion take place across the cross-welded surface, which are adjacent. So this lead to adequate cementing bonding of the particles to the cellular type, and this kind type of sintering can be seen in a pure tungsten um, by the way of sintering. So above the figure shows how the sintering process to the solid phase occurred, and the second one is liquid sintering, and one of the metal mats which penetrate in between the particles of the other metals, thus allowing results. And finally, continuous metallic bond is established as explained in mechanism of sintering. Production of sintered bronze and cemented carbide tips is typically done by this way. So we can see among the solid state there is a another particles present, and this is the one we get melts, and there's a wetting process engulfed in this liquid sintering. Next slide. So the finishing and the secondary operation will be the process which will be after the sintering process. So this finishing and secondary operation consists of sizing, cold pressing to improve the dimensional accuracy, and it can be in coining or pressing, which can be done in a cold working process to press details in the surface condension of sintered product like a coins coins, and impregnation with heated oil, self-lubricated bearings. Oil fills the pores of the part, which it consists of a oil among the pores. So infiltration, placement of slug of lower melting point metal against the center part, and infiltration of molten metal of capillary action. Pores are filled with the molten metal. And the last one will be heat treatment, plating, and painting. So above this figure, we can see that the finished product through the powder methodology, which is undergone. Initially, elemental or alloy metal powder will be going through a blending and mixing as mentioned at previously, and then they're going to a compaction, whether it can be a pressure or pressureless, and then with sintering, the sintering can be a solid sintering or liquid sintering, and after that they can be undergo optional secondary manufacturing or finishing. This is very optional, and this is optional for the manufacturers if they wanted a nice finishing. And the last one with the finished powder metallurgy product that we can look at the figure above. This is the example of the end product of metal powder metallurgy. That's it for me. Thank you.
and I'm Thipan here, and I'll be like giving the conclusion of this presentation. As we know, the powder methodology is the process that has made mass production parts easier. This is one of the best things has been like around the current technology. It has been available for a while now, but still advancing as technology keep increasing, which means like even more like high technology informations and like the methods are people are doing research and like developing. We have learned the definition types and the process, the application of the powder, example the sleeve, other type of casting of the powder methodology. We also examine its advantage and disadvantage of the specific targeted um, types of uh, methods. And that's all from me. Thank you.